Hi everyone, I'm Avdesh God. In this video, we will continue exploring the built-in functions in Tableau, especially the string and numeric functions. Well, let's get started. What if we want to find out if a string has certain ending or not? Let us find all the subcategories that ends with NES. We can easily use ends with function for this scenario. Let us build a calculation for the same. First of all, we will write the ends with function. It takes up two arguments. The first one is the field that we want to check if it ends with ES or not. The second argument is the substring or the pattern that we want to check at the end of the subcategory string. So in a nutshell, our string is subcategory and the pattern is ES. Let us hit OK and save this field. Let us bring this field to the view as well. The main difference between the contains and ends with function is that the contains function looks for the specified substring throughout the entire string, whereas the ends with checks it only at the end of the string. Let us change the value of the substring in case of both of these functions to understand these in a better fashion. As we have changed the substring to an R, in case of contains, if it finds an R throughout the string, it will set it to true, whereas in the case of ends with, the result is set to true only if a lowercase r is present at the end. Let us hit OK and view the results. In case of copier, we have got an R in the subcategory string, and that's why contains is set to true, whereas ends with is set to false. Whereas in case of paper, contains is set to true, reason being if at any position the substring is found in the string, then contains sets it to true, whereas in case of ends with, the result is set to true only if it is available at the end of the string. Now suppose if we want to add some spaces at the starting and ending of a string, we can do that using the space function. Let us quickly build a calculation for the same. But before that, let us understand what space function does. The space function expects only a single argument that is numerical in nature. And based on that number, It returns the number of spaces as an output. Let us use 3 spaces before the subcategory field and 3 spaces after the subcategory field as well. In that case, we will specify the argument as number 3. Thereafter, we will use the plus sign to concatenate the subcategory with the first space and the second space function. Notice, our calculation is valid. Reason being, the result of the space function is a string as well. Let us name this field as space subcategory. We will hit OK to save this. Let us now bring both the original subcategory field and the space subcategory field onto the text shelf. We will also bring the original subcategory field onto the row shelf as well. Over here, we can clearly see that in case of spaced subcategory, we have some spaces appended to the left and right of the subcategory. We may also have these leading or trailing spaces in the data in any field. In that case, we have got 3 functions to get rid of these leading or trailing spaces. Let us quickly understand those 3 functions first. The very first function is ltrim. It requires a string argument and returns the string without any leading spaces. That is, it will remove all of the leading spaces from that string. The second one is rtrim. This function will remove all of the trailing spaces from the string and will return the string without any spaces at the end. The last one is a combination of both ltrim and rtrim. That is, the trim function removes both the leading as well as trailing spaces. All of these functions expects only a single argument that is string in nature, whereas the returned one is also a string but without the leading, trailing, and both leading and trailing spaces respectively for these 3 functions. Let us quickly build a calculation for trim alone. We will enclose this space subcategory field or calculation into the trim function, and the expected output will be without any leading or trailing spaces. Let us save this and bring the same onto the text shelf. If we hover over, we can clearly see that there is no difference between the trim and original subcategory field, whereas the space subcategory field is having the leading and trailing spaces. Remember, while creating the trim field, we used the space subcategory field. So the trim function has removed all of the leading and trailing spaces, and that's why it's now equivalent to the subcategory original field. Let us now move around and discuss some of the most frequently used numeric functions in Tableau. If we create a new calculation and select numbers from the right drop-down, then we can see a wide list of numeric functions. What if we want to find the greatest integer of a number? That is, rounding of a floating value to the nearest integer of less or equal value. We have got a floor function for this. It takes up only one argument and converts it into the greatest integer. For instance, as the example mentions, 3.1415 will be converted into 3. Let us try this out with the sum of profits. We can see that our calculation is valid. In Tableau, we can easily wrap up one function into another, provided that we aren't breaking any aggregation rule. Herein, we are wrapping up the sum into the floor function. Let us name this as floor of profit. We'll hit OK to save this field. We will bring state onto the row shelf and profit onto the column shelf. Let us turn on the labels as well. The default formatting is not having any decimal places. Let us format the labels and include the decimal places as well. We will include only 2 decimal places. Let us now bring the floor of profit to the column shelf as well. For this as well, let us bring in the 2 decimal places by formatting the field. Over here, if we compare the 2 bar charts, we can clearly see how the floor function is performing its actions. For every state, the sum of profits is converted to the greatest integer, that is the value to the nearest integer of less or equal value. In case of Alabama, 5786 is the nearest integer value that is less than the actual sum of profits for Alabama. Whereas in case of Arizona, as the profits are negative, the nearest less integer value to this is 3428. Similarly, we have one more function called ceiling. It does exactly the opposite of the floor function, that is, rounds a number to the nearest integer of equal or greater value. We can quickly write up a calculation for the same as well. But this time, let us write the same onto the column shelf directly. We have enclosed the sum of profits into the ceiling function. Let us hit enter to confirm the same. For this as well, let us format to include 2 decimal places. As we can see, in case of Alabama, the flow function is providing 5786, whereas the ceiling function is providing the sum of profits as 5787, which is the nearest integer of greater value than 5786.83, which is the actual profit in case of Alabama. Now suppose we want to showcase the profits and loss using a separate field that we created earlier, and we want the value to be an absolute one. We can easily find the absolute value using the ABS function. The ABS function takes up only one argument and provides its absolute value. The argument that is provided to the absolute function should be numeric in nature. Let us create a quick calculation over here in the column shelf itself. As you can see, we have wrapped up the sum of profits in the ABS function. We will hit enter to confirm. For this as well, we will right click and format the same to include 2 decimal places. We can clearly see that how absolute function works. In case of Arizona, we had losses, that is, the profit was in negative. But over here, in case of absolute profits, for Arizona as well, the value we are getting is absolute in nature. We have few more important numeric functions. Let us discuss them one by one. At the end of this list, we have the Zn function, which means 0 if null. As the name of this function specifies, it returns the 0 value if the value passed to this function is null. Otherwise, we get the value of the field that we have passed to this function. As we can see in the example, in the right hand side, the Zn function takes one argument only. The next one is the square function. The square function can be easily used to find the square of any number that we are having in a field. As we can see, it takes up only a single argument that is numerical in nature and returns the result in numerical format as well. The opposite of it is the square root function, which again takes a single argument that is number and returns the square root of that number that is again numerical in nature. Thereafter, sine is an important function. It returns 1 if the number is positive, 0 if the number is 0, or -1 if the number is negative. Let us quickly create a calculation for this using the sum of profits. Let us save this and bring the same over to the view. As we can see, we have segregated the information of profits and losses into two fields. The absolute function has returned us the absolute value of profits or losses without specifying whether it's a profit or a loss. Whereas on the other hand, the sign function is providing us the information whether it's a profit or a loss. Let us discuss some more numeric functions to get to know more about them. We have a minimum function which can be utilized in two ways. The very first one that we can see on the right hand side takes up a single argument and returns the minimum value out of the entire dataset for that particular field. Whereas in the second format, the minimum uses two expressions and returns a row-based operation. That is, if we write a calculation, minimum of sum of profits and minimum of discount, then it will return a minimum value out of profit and discount based on a row-based operation. The first one, on the other hand, was a column-based operation. Other function is maximum. This is exactly similar to the minimum function. Its operation is exactly similar to that of the minimum function, but returns the maximum value. The first use of it returns a column-based maximum. Suppose if we write this function as maximum of sales, then it will return the maximum of sales out of the entire column. Whereas in the second case, if we write maximum of sales or profits, then it will return a row-based operation by comparing both sales and profit for that particular record and returning the maximum of both. We also have a division function which takes up two arguments. Both are integer in nature and returns an integer as a part of that division. We have one more function that is quite often used, that is round. It takes up two arguments. One is number and the second is the decimal places till which we want to round the number. Let us quickly write this for the sum of profits. Notice, if we do not specify the decimal places, then this function does not give us any error. Reason being, by default, it will round off the sum of profits to 0 decimal places. But for the time being, let us set up the decimal place to 1. We will hit OK, bring this field to the view, and format it to have 2 decimal places. If you notice, the second decimal place is set to 0 in case of Alabama, whereas the actual value of profit is having 3 at the second decimal place. Reason being, we are rounding it off based on 1 decimal place. Let us quickly edit this calculation and change it to 0 decimal places. Once we hit apply, the results will change accordingly in the view. Even if we remove this 0, the default rounding off will be up to 0 decimal places. We will hit OK and the calculation will not change. In the next video, we will explore about the type, logical, and date built-in functions in Tableau.